Hello, ladies and gentlemen. So today we're going to look at the letter E in math. So what you're going to want to have: notes, a calculator. If you have a graphing calculator, that could be good. Also, Desmos is a good thing to have maybe on you. Pen or a pencil, and then I gave you two little graph papers today. Make sure you have those also to be able to use in your notes. So, do you remember pi? Talked about pi. Pi day is coming up, actually. So what does pi represent? You guys remember pi was a number. It's an irrational number. It's 3.14159 such and such. So there are other irrational numbers like that too. But what if we could simplify some expressions containing pi? So on this, you would have just given that 2 to both of them, right? So you'd have had 5 to the second, pi to the second. Well, 5 to the second, that's just 25. Right? 25 pi to the second? That's pretty simple, right? What about this one? So we would simplify the 15 and the 20, right? And we would take a 5 out of both of them, because that's a common multiple. We'd have 3 over 4. What are we going to do with this, though? Pi to the negative 1. We're going to move that to the top, right? It's negative, so we're going to take that and it's going to go all the way to the top. So we would have pi to the 5 plus 1, pi to the 6th power. So pi is irrational. We also have one called the Euler's number. This is actually pronounced Euler. That's how you pronounce that. Euler's number. So E stands for Euler is 2.71828 ... It goes forever and a day. It's one of the most important numbers, along with your I and your pi. So someone realized long ago that this E came from somewhere. So do you remember this exponential growth formula we talked about? Well, they realized that if you do it for a year, compound per year, compound for a day, or a month each year, a day each year, what about an hour each year? That'd be amazing, wouldn't it? What about each minute for 1 year you would compound? What's amazing is that this goes exceptionally close to E. So this allows you, this is how they found E. They saw it actually, stuff grows by E. So they realized that why can't we have this in our function? That way we don't have to remember 2.71828. So we're going to make sure we want to be able to simplify this stuff when we have an E in it. Just kind of like when we would have an X in it, but ultimately you can actually get a number for it. So let's combine this. I have a 2 and I have a 6. We can multiply that together. So we get 2 times 6. It's going to give us a 12. These two got 2 E's. Treat them like X's. So what would we do with those exponents? We'd add, right? So negative 3 plus 5, that's 2. So 12e to the 2nd power. What about b here? So just like last time, we're going to simplify here. 24 over 4, that is 24 divided by 4. That's just 6, right? And then what are we going to do with these exponents right here? This 8 and this 5. There's division, right? So division, we would subtract. So we're going to go 8 minus 5, 3. So we have 6e to the 3rd. Now, unlike when you had x's, you can actually evaluate this. You can actually plug this into your calculator. So you're going to want to find your e to the x button. It looks like it's an e, and then it usually has a little x. If you need help tomorrow trying to find it, let me know. I will help you find it. It's somewhere on your calculator, hidden somewhere, probably with the log. It's probably near LN. It's probably going to see it near the LN button. Good choice to find that. It's probably around that area. This one, 12e to the 2nd power, that is 88.67. And then this one, 6e to the 3rd, that's 120.51. So take a look on your calculator, see if you can find your e to the x power, and see if you can get these answers on your calculator. Otherwise, it's going to be a little harder. But like I said, if you can't find it, ask me tomorrow. I will find it for you on your calculator. Let's try C. So this, remember, you're going to give that 3 to everybody on the inside. So we're going to get 4 to the third power, e to the 2 times 3. That's going to be 6x, right? 4 to the third, that's 64. E to the 6x. We can't do anything else because there has an x in there. You can't evaluate when you have an x. So that one is as simple. It's just simplifying. We're not going to evaluate on this one. So what else can we do with e? What else do you think we can do with e? We can graph it. Of course, your favorite thing to do in the world, right? So we're going to graph the natural base e exponential function. So it's going to look something like this. F of x equals e to the x. Your x's can always look like -2, -1, 0, 1, and 2, unless you have something in here. Kind of like what we did for the growth and x did k, right? Looks about the same. So if I plug in -2, you're going to get e to the -2. And what you should get 0.14 for that part. This is e to the -1. That is 0.37. E to the 0 is 1. E to the first is 2.72. Notice I'm just taking that x and I'm just putting it in for the x up here. So e to the second is 7.39. Let's try graphing these. So I got -2, 0.14, about right there. -1, 0.37, about right there. 0, 1, 2.72, and 2, 7.39, about right there. So if I can connect my dots, hopefully I can. Oop, I'm on a roll, I'm on a roll. Yeah. Nice finish. So now, is this a growth or decay graph? What do you think? Did you say growth? Because you're right, if it is growth. So it is a growth graph. Notice how it's going up. So just like on our growth graphs before, this one also has a asymptote right here. So my asymptote is y equals 0 on these particular graphs. So these are also going to have asymptotes that you're going to see. Let's take a look at this one. So we have e to the -x plus 1. So every time I'm going to do it, I'm going to have to change your x to the other sign and then add 1. So this is technically going to be e to the second plus 1. You see how that is? Because I had a -2. -2 is a +2. That is 8.39. If I plug in a -1, we get 3.72. Plug in a 0, we get 2. Plug in a 1, 1.37, and 1.14 finishes out the round there. So -2, 8.39, about right there. -1, 3.72, about right there. 0, 2 goes about right there. 1, 1.37, and 2, 1.14, about right there. So let's go ahead and connect our dots here. Oop, almost missed that one. There we go. So now, is this a growth or decay graph? You're right, it is a decay graph, and its asymptote is right here. At +1. So my asymptote is y equals 1. Just make sure you watch out for that. I know I'm probably going to be asking you about asymptotes and whatnot on these ones, just so you practice further on that. But that's the end of this video. This is Miss Marsh, signing off.